Okay, so I'm just concluding and wrapping up part 2, this try it out. As we looked at in trapezoid M and PQ, these two sides are parallel, and then we're given information that this angle is 108, that's 3x plus 21, and this is 4x minus 15. Okay, so we drew the diagram. And now we're being asked what's the relationship between angle M and angle Q. So in a trapezoid, same side interior angles, I lost my pen, that's why I'm using this marker. Same side interior angles are supplementary. And that's the case here. We have a set of supplementary angles. Let me raise this up a little bit. So same side interior angles are supplementary. And this angle here and this angle here are same side interior angles. Determine and state the measure of angle N. So in order for me to figure that out, I would need to take this and get 180, but I don't have any information here. So I'm going to use this set of angles, 108 plus 3x plus 21 is equal to 180. So then we take 21 and 108 and add them, and that's 129 plus 3x equals 180. Then we subtract 129 from both sides. That's going to give us a 7. So we end up with 51. Divide both sides by 3. And, that's a 1. And we get 17. Okay? So, if 17 is x, then I'm going to plug it in here. 4 times 17 minus 15. Okay, I'm just going to multiply it on the side here. 4 times 17, that's 8. 68 minus 15 is 53. Hopefully I calculated correctly. 17 times 4, 82, that's 68 minus 15 is 53. So that means this here is 53, and N is 180 minus 53. Okay, so you take 180 minus 53. That's 7. 1, 7. Okay, and so this is 127. All right, so the measure of angle N is equal to 127. So just backtracking and looking at the work we did, here it states that in trapezoid M and PQ, these two sides are parallel. And these two angles, just because of what we know about trapezoids, are supplementary. What's the relationship between angle M and angle Q? Same side interior angles are supplementary. That means they add up to 180. Then we're asked to find N. In order to find N, we have to know what X is. We solve for X by taking these two angles and adding them up and making them equal to 180 because they're supplementary. Once we did that, we came up with an equation that solved for X, and for X we got 17. So X is equal to 17. Then we plugged that 17 back into this angle here, and we got 53. To figure out what N is, we would have to subtract 180 from 53 because these are supplementary. Okay, let's go on to the proof in the back. And it states that ABCD is an isosceles trapezoid with bases BC and AD. right? So it's an isosceles trapezoid, meaning these two are congruent. And congruent legs, AB and CD. Okay? So if this is an isosceles trapezoid, that means that this angle here and this angle here are congruent. And we're also told that BE is congruent to CD. So BE is congruent to CD, and we're trying to prove that angle A is congruent to angle BEA. So we're trying to prove that it's congruent. These two angles are congruent to each other, okay? So the way we start any proof is by writing the statements and the reasons. So statements, reasons, okay? And first statement is the given information, okay? So, in the interest of time, I'm not going to write out the given. It's just going to take too long. You should never not write out the given. You always will have to. I'm not because I got to go, okay? Segment AB is congruent to segment BE. AB is congruent to BE. Why is that? The transitive property of congruence. The transitive property of congruence is more complicated than it sounds. Essentially, it tells us that if AB is congruent to CD or BE is congruent to CD, then AB is congruent to BE. If these two are congruent and these two are congruent, then these two are congruent, is basically what it states, okay? Transitive property of congruence. Then, triangle ABE, we're making this as a statement, is an isosceles triangle. How do we know that? How do we know that? An isosceles triangle has two congruent sides, and those are AB and BE. Okay? And the final statement is what we're proving, which is that angle A is congruent to BEA because base angles just means these two angles here. Base angles in isosceles triangles are congruent, okay? All right, so the last thing we're going to talk about because of the IXL assignment that you have is the case of you having a trapezoid with a mid-segment, and so those can be kind of tricky, okay? And I'm just going to talk about that really quickly. So a trapezoid, like we said, is, it's a quadrilateral, of course, 4 sides, and one or more pairs of parallel sides. Excuse the noise. I don't know if those are your 10th grade peers making a whole lot of noise. All right, so when you have a trapezoid with a mid-segment, in order to figure out the length of the mid-segment, you need to take the average, okay? So what do I mean by that? What you would do is take the length of this side here and the length of this side, right? The length of the parallel sides, and divide it by 2 to get this side here, or to get this mid-segment. For example, if this were 10 and this side were 12, in order to figure out this side, I would take 10 plus 12 divided by 2, and that would give me 11. That would tell me what the length of this side is. What about the reverse of that? Right? So if I had another situation where I have this trapezoid with a midsegment, and I'm given that this is, 8, and that's this midsegment here in the trapezoid is 4. How do I know what this third side is? Well, I would take 8 plus x is equal to 4. 8 plus x divided by 2, rather, is equal to 4. Okay? 8 plus x, because this side would be the side that's unknown. We have to take 8 plus x divided by 2 and set it equal to 4. Right? So multiply both sides by 2, and then we would get 8 plus x is equal to 8. And this one wouldn't be feasible because, of course, x would be equal to 0, and that's not a feasible length. So we should have changed this to something else. And, of course, because this is going to be half of it, then that's the reason why we got 0 as our answer, okay? You will be doing an IXL assignment tomorrow that deals with not just the properties of our typical trapezoids, but also of trapezoids with midsegments. So you'll see some of these, but then you'll see some trapezoids with midsegments, and I trust that you'll be able to figure them out to the best of your ability. I will see you Wednesday.